Hello. So we are now moving into the last topics of section 4.3. The first of these last topics deals with the probability of at least one formula. So whenever you see at least one, you always have to think of one or more objects. So the formula that we use, because sometimes it's too cumbersome to list all the objects, so we have a nice compact formula that we can apply. The way it's written here, it says the probability of at least one, think of it as 1 minus the probability of none. And let's demonstrate this in an example. So let's assume a coin is flipped 3 times. We compute the probability of getting at least one tail. Well, if we're flipping a coin 3 times, that means we're going to have 3 outcomes. So what I've done is I've listed all the outcomes. You could have 3 heads, 2 heads and a tail, heads, tails, heads, etc. Altogether, there are 8 different outcomes. Now, when the question is asked at least one, what that's saying is we have to have one or more tails. So let's go ahead and just count the outcomes that produce one tail. So there's one tail, one tail, one tail, 2 tails, 2 tails, 2 tails, and then finally 3 tails. Remember, at least one tail means one or more tails. So it turns out that there is 1, 2, 3, 4, 5, 6, 7 ways of getting at least one tail. So 7 out of 8. So that would be somewhat of a long way of coming up with the answer. It looks short here because we have a limited number of outcomes, but we can also simply apply the formula. The formula, remember, it's 1 minus the probability that none of the outcomes are tails. In other words, they're all heads. Well, there's only one situation where it's all heads, so it's 1 minus 1 out of 8. When you perform the calculations, you end up getting the same answer, 7 out of 8. So you can see that applying this formula, I kind of tend to think of it as a shortcut to getting our answer, especially when we have really large sample spaces. So let's take a look at another example. It says if a student has a 75% chance of passing a history of rock and roll course and 4 students are chosen at random, find the probability that at least one will pass the history of rock and roll course. So remember, you have 4 students. You want to know what's the chance that at least one of those 4 will pass. Well, the pass rate for history of rock and roll is 0.75. That means those who will not pass will be 1 minus 0.75, so the probability of not passing is 0.25, right? These two should add up to 100%. So when we apply our formula, the probability that at least one passes history of rock and roll, well, that's 1 minus the probability that the person does not pass the history of rock and roll is 0.25, and we raise that to the 4th power because there's 4 students that we're choosing. And then we just perform our mathematical calculations, and we see that this probability is equal to 0.996. So there's a high chance that one or more of the 4 will pass history of rock and roll. Sounds like a great class. And then I have another example. I'll have you folks, you could pause the video and work on this example here. It's just more a demonstration of how the at least one formula works. So work that through, and if you have questions, let me know. But we're going to go on to some other examples. There's about 3 examples here that we're going to tackle. So let's go ahead and I'm going to work out this 3rd example here, and then I'll work out another one. This is an example of where we have independent events, because we're collecting a small sample of 4 people. And it's from a large population, because it's just saying a random person. This could be out of, we'll just say in America, it could be out of 300 million. So when you have independent events, the probabilities never change. So let's work this probability out. Once we see our keyword, 3 keywords there, which is at least 1, so that tells us we will apply the formula. So the formula says the following: it's 1 minus the probability that none is a Rams fan, LA Rams fan. So we want to calculate this probability. So we're looking for the probability that at least one of these 4 people will be an LA Rams fan. So to do that, we're using our formula, 1 minus the probability that none of them are LA Rams fans. Well, what's the chance that a person's not an LA Rams fan? Okay, that's going to be, the chance is 32%. So what's 1 minus, or 100 minus 32%? That's 68%. So the chance that a person is not an LA Rams fan is 68%. So let's go to the next step. So that means we're going to change this notation to 68% because 68% of people are just not LA Rams fans. And we're just, I think the population is here in LA, so it's not nationwide. So let me just correct that. It should just be in the LA region, which is still a large population. It includes millions. And then we're going to raise this to the 4th power because we're selecting 4 people. And these are independent events. So if the events are independent, we don't modify the probability. It just remains the same per calculation. So let's calculate this. So we have P is equal to one minus, let's type 0.68 to the 4th power in our calculator, and we end up with, we'll round to 3 places, 0.214. And so 1 minus 0.214 will give us the following probability. 0.786. So we can say for the LA area, at least 78.6% of people, well, of the 4 people are LA Rams fans. Okay, so let's move on to another problem. Let's take a look at, we'll go ahead and work out this problem number 4 here. This would be an example of dependent events because now we have a limited number of items. We have 6, so let me just read the problem first. A person owns 6 bonds, 3 stocks, and 2 mutual funds. If 3 investments are chosen at random, find the probability that at least 1 bond is chosen. So here we only have 11 items, right? We have 6 bonds, 3 stocks, and 2 mutual funds, whereas here we were selecting from a larger population for problem 3. So we're going to be using dependent events here. So that means every time we select an object, we have to remove it from the probabilities. So the probabilities change per selection. So we want to find what's the probability. Let me just highlight this information. The probability of selecting at least 1 bond. Okay, so let's write this down. So we have P is equal to 1 minus the probability that the investment we select is not a bond. So that's P equal to 1 minus So how many objects are not bonds? Well, we don't include the bonds. We include the 3 stocks and the 2 mutual funds. So that's going to be 5 out of 11. And then once we select that investment, we can't reselect it again. It's gone. We sell it or we put it aside. So now the probability that the next item we select is not a bond is 4 out of 10 because we're reducing our selection. There's only 10 investments and one item that's not a bond has been removed. And finally, we have for the last non-bond investment, we only have 3 choices or 3 possibilities out of 9. And so let's go ahead and perform the calculation to see. We get 1 minus, let's multiply. So we're going to multiply 5 out of 11 times 4 out of 10 times 3 out of 9. And that's going to give us 2 out of 33. So it's 1 minus 2 out of 33 after you perform the calculations. And finally, 1 minus 2 out of 33 is 31 out of 33 when you subtract 2 out of 33 from 1. And of course you could work with decimals if you feel more comfortable with decimals. And just remember your calculators do have a fraction button that makes it a little easier to perform the calculations. Go ahead now and work out these other examples. And that will complete our topic on at least one. So pause the video, work on these problems, and when you're ready, we're going to move on to our next topic, which deals with trees. Okay. Continuing with trees. So we did talk about trees previously. Now trees are just constructs that allow us to list all the possibilities for a sequence of events. But we can also compute probabilities using trees. So it turns out for each branch we can assign a probability, and then as we move down a pathway we multiply adjacent probabilities to get to a particular answer. So let's take a look at an example. It says a room contains 2 identical jars. In jar 1 there are 4 blue balls and 3 red balls. And then we have another identical jar that has 4 blue balls and 6 red balls. So if a jar is randomly selected, followed by the selection of a ball, compute the following, or compute the chance of selecting a red ball. So step 1 is to construct our tree diagram. So first we enter the room, so that's this node represents the selection of a jar. We either select jar 1 or jar 2. Now if we select jar 1, we could select a red ball or a blue ball. And the same holds for jar 2, red, blue. So after we've constructed our tree diagram, we then assign probabilities to each branch. So remember, we have 2 identical jars, so the chance of selecting jar 1 is 1 out of 2 chances. And the chance of selecting bar 2 is also 1 out of 2. And just, I want to point something out here. When the branches emanate from one of these nodes, the probabilities must always add up to 1. So 1/2 plus 1/2 is 1. And that's going to hold for each node. So let's take a look. So what if we select jar 1? What's the chance of selecting a red ball? Well, if we go back, we have 3 red balls out of 7. So there's 3 out of 7 chances of selecting a red ball. That means there's 4 out of 7 chances of selecting a blue ball. And following that reasoning, for jar 2, we have 6 red balls out of 10. So probability of selecting a red ball is 6 out of 10, a blue ball 4 out of 10. Okay. And then to get to our answer, what we need to do is since we're looking for the chance of selecting a red ball, we have to follow all the pathways that lead to the selection of a red ball. So pathway 1 tells us if we select jar 1, there's a half a chance of doing that. Then there's a 3 out of 7 chance of selecting a red ball. So pathway 1 will lead to 1/2 times 3 out of 7, which is equal to 3 out of 14. So that's the probability of selecting a red ball if we choose jar 1. Now if we instead choose jar 2, we're going to have a second pathway. So if there's a half a chance we pick jar 2, and then there's a 6 out of 10 chance of picking a red ball. So we multiply that out, and we end up with 3 out of 10. So if we pick jar 2, there's a 3 out of 10 chance of selecting a red ball. So the final step to get our answer, the probability of selecting a red ball, we just add these two probabilities together. 3 out of 14 plus 3 out of 10, that's equal to 18 out of 35. And as I said before, if you feel more comfortable working with decimals, you can just convert 18 out of 35 to a decimal. And we have a few problems for you to try involving the tree diagram. Go ahead and take time to work on those problems, and then just contact me if you have questions. We'll post some of the answers up later on. But that's going to conclude the video. Just keep working hard, folks. I know it's a challenging time, but stay motivated. I think we'll get through this whole remote learning process and get back to class. I look forward to seeing everyone hopefully on April 6th. Take care.